problem, the dividend tells us how much we have. The divisor tells us how we want to group or share it. But what happens in a division problem is 0 is the divisor. Let's start with 6 items. We want to put them into 0 groups. How many items are going to be in each group if we have 0 groups? This means we are solving 6 divided by 0. 6 is my dividend, 0 is our divisor. So I want to put these 6 items into 0 groups. Well, if I have 0 groups, that means I don't have any groups. So I can't move my items into groups if I don't actually have any groups. Well, what happens if we change our dividend to a larger number? What happens if I try to do 12 divided by 0? We have more in our dividend, but our divisor is still putting them into 0 groups. So I still don't have any actual groups to move my items to. Anytime I try to divide by 0, the result is impossible. It's going to come out to be an empty or null set because I don't actually have any groups to move my items to. Anytime we try to divide by 0, we're going to run into this problem. When 0 is our divisor, the result is an empty set or a null set. Calculators will often show this as an error in the display when you try to do it. It isn't that you made a typo, the problem is it's not mathematically possible to do this. In a division problem, the dividend tells us how much we have. The divisor tells us how we want to group or share it. What happens in the division problem if we use 1 as a divisor? Well, let's start with 4 items. We want to put those into one group. This means 4 is our dividend and 1 is our divisor, so we're solving 4 divided by 1. If I want to put my 4 items into one group, that means everything gets moved into that one group. So 4 divided by 1 gives me 4. Well, let's see what happens if we have a larger dividend. What if I have 12 items? So 12 would be my dividend, and I still want to put them in one group, so 1 is my divisor. That means I'm solving 12 divided by 1. Well, if I want to arrange my 12 items into one group, again, that means everything is going to have to go into that one group. So 12 divided by 1 gives me 12. If we divide by 1 enough times, we notice there's a pattern developing. Anytime we divide a number by 1, the solution to that problem, or the quotient, is always going to be the same as our dividend. Anytime a number is divided by 1, the quotient comes out to be itself. Any number that is an even number can be divided by 2. Even numbers end in 0, 2, 4, 6, or 8. Let's try a few different examples. We're going to start with 12 items, and we want to split those 12 items into 2 groups. So 12 is my dividend, and 2 is my divisor. 12 is an even number because it ends in 2. So as I start to work to split those 12 items into 2 groups, we should notice that everything is going to go into 2 groups with nothing left over. I can put 6 items into each group. So 12 divided by 2 gives me 6. But what if I'm working with a number that isn't an even number? What if we start with 9 items? 9 doesn't end in 0, 2, 4, 6, or 8. So what happens when I want to solve 9 divided by 2? Well, again, we can work to put all of our items into 2 groups. When we do that, though, we notice we're going to have 1 left over. So when I solve 9 divided by 2, I get 4 items in each group and 1 left over. Anytime I'm working with an odd number or a number that isn't even, this is going to happen, that I'm going to have a remainder. A number is going to be divisible by 3 if the sum of all of its digits is divisible by 3. To check this out, we're going to start with a list of multiples of 3 since we know they are divisible by 3. Here's a list that includes the first 10 multiples of 3. Let's test out our rule using one of these values since we already know it's divisible by 3. We'll start by using 15. If we add our digits together of 15, 1 plus 5 gives me 6. 6 is on our list of multiples, so we know it should be divisible by 3. Therefore, 15 should be divisible by 3. Well, let's test it out. We have our 15 items for our dividend that we want to split into 3 groups for our divisor. We can see that everything is going to fit evenly into 3 groups with 5 items in each group. So 15 divided by 3 equals 5. Since the sum of the digits of 15 is divisible by 3, the original number of 15 is divisible by 3. What if we test a number not on that list? What if instead of starting with 15 items, we start with 13 items? Well, let's start by adding together our 1 plus 3 and 13. 1 plus 3 gives us 4. 4 isn't a multiple of 3, so when I divide 13 items amongst 3 groups, they shouldn't go evenly. As we do that, we can see that I wind up with 4 items in each group with 1 remainder. So 13 divided by 3 gives me 4 remainder 1. Since the sum of my digits in 13 isn't divisible by 3, my original number of 13 isn't divisible by 3 either. Another way to determine if a value is divisible by 4 is by dividing our original number twice by 2. Multiples of 4 can be divided by 2 twice and still have a whole number quotient. Well, let's test that using 12 items. I want to know if my 12 items can be divided evenly into 4 groups. Well, dividing 12 twice by 2, I would start by doing 12 divided by 2, which would give me 6. 6 divided by 2 would give me 3. 3 is still a whole number, so that means I should be able to split 12 into 4 groups and not have any remainders. When we do that, we can see we wind up with 3 items in each group. So 12 divided by 4 gives me 3. Dividing the number twice by 2 is going to give us the same result also as simply dividing by 4. This time we're going to start with 10 items. We want to split our 10 items into 4 groups and test to see if it's going to go in evenly without any remainders. Well, we'll start by dividing 10 by 2 twice to test it out. 10 divided by 2 gives me 5. 5 divided by 2 gives me 2 with 1 left over though. So if I try to divide my 10 items into 4 groups, I should wind up with a remainder. And sure enough, when we do, 10 divided by 4 gives me 2 per group with 1 left over. So 2 remainder 1 is the same solution we also got when we divided it twice by 2. So either way, we're going to find out if our value is divisible by 4 and come out with a quotient. A number is divisible by 5 if it ends in 0 or 5. Let's test it out using a couple different examples. Here we have 10 items that we want to split into 5 groups. If we start taking our 10 items and placing them into our 5 groups, we can see that we can put 2 items into each group. So 10 divided by 5 gives me 2. 10 ends in a 0, therefore it's divisible by 5. This time we have 15 items that we want to divide amongst 5 groups. As we start placing our 15 items into our 5 groups, we can see that we're going to wind up with 3 items in each group. 15 divided by 5 gives me 3. 15 ends in a 5, therefore it's divisible by 5. But is it true that if the number doesn't end in a 5 or 0, it's not going to be divisible by 5? Let's test it one more time using 12 items. As we start dividing our 12 items amongst 5 groups, we can see that we can put 2 items in each group. However, we also have 2 items left over. So if I try to do 12 divided by 5, I come out with 2 items per group and a remainder of 2. Since 12 doesn't end in 5 or 0, it's not going to be divided by 5 evenly. Well, if a number is divisible by 6, then it's also divisible by 2 or 3. Numbers that are divisible by 2 are even numbers, meaning they end in 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of its digits is also divisible by 3. Well, let's test this out using the problem 12 divided by 6. You can see that if we take our 12 items and split them into 6 groups, we can put 2 items into each group with no remainders. So 12 divided by 6 gives us 2. Let's look more closely at the 12, which is our dividend. It should be divisible by 2 and divisible by 3. At the end of the 12 in the ones place is a 2, so it's an even number, which tells us it's divisible by 2. If we add together its digits, 1 plus 2 gives us 3, which tells us it's divisible by 3. So yes, 12 is divisible by 6, like we see from our model. Now we'll test out dividing 15 by 6. Here we can start arranging our items so that we have the same number of our dividend put into each group of our divisor. When we do, we can see that we still have 2 items in each group, but now we have 3 items left over. There's not enough to put one of these items into each of these groups. So 15 divided by 6 gives us 2 remainder 3. If we look at 15 more closely, we can see that it's an odd number, which tells us it's not divisible by 2 because it ends in a 5. However, if we add together the sum of its digits, 1 plus 5 gives us 6, and 6 is divisible by 3. But in order to divide by 6, it has to meet both of those rules. Since it's only divisible by 3, it's not going to be divisible by 6 without having a remainder. In a division problem, the dividend tells us how much we have, and the divisor tells us how we're going to group or share it. If we want to know if a number is divisible by 7, there's a few steps we're going to have to go through to test the dividend. First off, in our dividend, we need to double the ones place. In our first problem, we have 343 divided by 7. 3 is in the ones place, so the first thing I need to do is double that 3. When I double that 3, I have 3 times 2, that gives me 6. Our next step is to subtract the results from the remaining digits. Well, the remaining digits are 34, so that means I'm going to have to subtract that 6 from 34. When I do 34 minus 6, that leaves me with 28. At that point, I can check to see if my number is divisible by 7. Looking at our list of multiples of 7, we can see that 28 is on the list. That means 28 is divisible by 7. If we weren't sure, we could repeat steps 1 and 2 with 28 and test again and get the same results. But since we know 28 is a multiple of 7, we know this tells us that 343 is going to be divided by 7. To test it, we can actually do 343 divided by 7. 7 is going to go into 34 4 times. 7 times 4 is 28. 34 minus 28 leaves me with 6. From there, I can bring down my 3. 7 goes into 63 9 times, and from there, I don't have any remainders, just like I predicted. Let's test this out with another example. We have 125 divided by 7. Again, our first step is to double the ones place. 5 is in the ones place, so that means I'm going to have to do 5 times 2. 5 times 2 gives me 10. My next step is to subtract the results from the remaining digits. Well, my remaining digits are 12, so that means for my second step, I'm going to have to do 12 minus 10. 12 minus 10 leaves me with 2. Well, now it tells us that if our result is a multiple of 7, then our original number is going to be divisible by 7. If we check our list of multiples of 7, 2 isn't on that list. The smallest number is 7. So that tells me 125 divided by 7 is going to have remainders. It's not going to come out even. If we go ahead and test it, I have 125 divided by 7. Well, if I start dividing, 7 goes into 12 once. Subtract out 7, that leaves me with 5. Bring down my remaining 5. 7 goes into 55 7 times. Subtract out my 49. 55 minus 49 leaves me with 6. So as predicted, we don't have a whole number. We have 17 remainder 6 instead. Here we have 24 items for our dividend that we want to divide into 8 groups for our divisor. If 24 can be divided by 8 evenly, we should have no remainders. And when we're done, we see we can put 24 items into 8 groups with 3 items in each group. Now there's a way we could have checked to see if 24 was going to be divisible by 8 before we could divide it. If numbers are divisible by 8, our dividend can be divided 3 times by the number 2 and still result in a whole number. Well, let's test that out. Our dividend was 24. So first, we would divide 24 by 2, which gives us 12. That's a whole number, so let's go to our second trial. 12 divided by 2 gives us 6. That's a whole number, so let's go on to our third trial. 6 divided by 2 gives us 3, which is still a whole number. So since we were able to divide 24 by 2 3 times and still come out with a whole number, we know that 24, as we see, is divisible by 8 with no remainders. Let's test another value. This time we have 18 items that we want to divide into 8 groups. If 18 is divisible by 8, then I should be able to put the same number of items in each group and not have any remainders. When I do that though, I see that I can put 2 items in each group, but then I also have a remainder of 2. These 2 items can't be divided equally amongst those 8 groups, so 18 divided by 8 gives us 2 remainder 2. If we tried to test this out mathematically by dividing 18 by 2 3 times in a row, we would see on our first division, 18 divided by 2 gives us 9. 9 is a whole number, so we can continue on to the next one. 9 divided by 2 gives us 4 remainder 1. 4 remainder 1 isn't a whole number, so we can't divide it a third time by 2. So that also tells us that 18 is not going to be divisible by 8, which matches up with what we see here in our example. Well, if a number is divisible by 9, then the sum of its digits is divisible by 9. Let's start with a list of multiples of 9 so we can compare. Multiples of 9 include 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, and so on. Let's start by testing out one of those values. We have a dividend of 18 that we want to divide into our divisor of 9. 18 is on our list, so we know it's a multiple of 9. But if 18 is divisible by 9, that tells us we should be able to put the same number of items in each group with no remainders. When we do that, we see that 18 divided by 9 gives us 2 items in each group. Now let's test our rule. The sum of the digits should be divisible by 9. So let's take our dividend of 18. For 18, I'm going to add together the 1 plus the 8. 1 plus the 8 gives us 9. 9 is also a multiple of 9, so that we see 18 should be divided by 9 with no remainders. Let's test this out using another value. Here I have a dividend of 12 that I want to put into my divisor of 9. If 12 is divisible by 9, then I should be able to put the same number of items into each group with no remainders. As we go through, we can see that I can only put one item into each group and I have 3 items left over. I can't evenly distribute these 3 items over my 9 groups. So 12 divided by 9 gives me 1 remainder 3. If I tested this out using my divisibility rule for 9, I would need to add together the digits of 12. 1 plus 2 gives me 3. 3 isn't on our list of multiples of 9, so again that would tell me that 12 is not going to be evenly divisible by 9. Well, numbers that end in 0 are divisible by 10. Let's try an example here. Here we have a dividend of 20 and we have a divisor of 10. So we want to solve 20 divided by 10. 20 ends in a 0, so that means I should be able to put 20 items into 10 groups with the same number of items in each group and none left over. When we do that, we see 20 divided by 10 gives us 2. So that proves our theory so far that numbers that end in 0 are divisible by 10. Let's try another example this time that doesn't end in 0. Here we have 12 that we want to divide into 10 groups. 12 does not end in 0, so that means we should not be able to divide it out evenly. Since 12 does not end in 0, we're probably going to have remainders. And we can see as we divide it out, with 12 items divided by 10, we can put 1 item in each group with 2 items left over. 12 divided by 10 gives me 1 remainder 2, which again goes along with our theory that numbers that end in 0 are going to be divisible by 10. Let's start by doing an example. Here we have a dividend of 22 items that I wanted to divide into my divisor of 11 groups. If 22 is divisible by 11, then I should be able to put the same number of items in each group without having any remainders. As we go through, we can see that if I have 22 items split into 11 groups, I have 2 items in each group. So 22 is divisible by 11. Matter of fact, there's a pattern to all the numbers under 100 that are divisible by 11. If a value is divisible by 11, it will have the same digit in the ones and the tens place. So under 100, this would include 11, 22, as we see here, 33, 44, 55, 66, 77, 88, and 99. Let's test this out again with a different value. Here we have a dividend of 16 that we want to split into 11 groups. If 16 is divisible by 11, then I should be able to put the same number of items in each group and not have any remainders. As we go through, we can see that we can put 1 item into each group, but then I have 5 items left over. I can't put these 5 items evenly into these 11 groups. So 16 divided by 11 gives me 1 remainder 5. If we compare that to our rule so far, 16 is under 100, so to be divisible by 11, it should have the same digits in the ones place and the tens place. 16 has a 1 in the ones place and a 6 in a tens place. That's 2 different digits, so it shouldn't be divisible by 11, which is what we see here in our example. Well, if a number is divisible by 12, that means it's also divisible by 3 and 4. This means we need to know the divisibility rules for 3 and 4. If a number is divisible by 3, that means the sum of its digits is divisible by 3. And if a number is divisible by 4, then the last 2 digits of that number are also divisible by 4. Well, let's test this out. Here we have a dividend of 24 that we want to divide by a divisor of 12. That means we need to put 24 items into each group with nothing left over and no remainders. So we go through, we can see that as we separate our 24 items into 12 groups, we can do so by putting the same number of items in each group. 24 divided by 12 gives us 2. Now let's test that with our divisibility rules. If 24 is divisible by 3, then that means the sum of its digits is divisible by 3. 2 plus 4 is 6, and 6 is divisible by 3. It should also be divisible by 4. Well, 24 only has 2 numbers in its digits, so we just have to check 24. 24 is divisible by 4. So since it's divisible by 3 and 4, we can see that 24 is also divisible by 12, and it follows our rule. Let's test out another example. Here we have 16 divided by 12. If 16 is divisible by 12, that means I should be able to put the same number of items in each group without having any leftovers or any remainders. But as we can see, when we start to divide 16 by 12, I can put one item in each group and then have 4 items remaining. So 16 divided by 12 is 1 remainder 4. If we test that with our rules, we can check to see if 16 is divisible by 3 and divisible by 4. Well, for being divisible by 3, I would need to add together the 1 and the 6. 1 plus 6 is 7. 7 is not divisible by 3. On the other hand, 16, checking the last 2 digits of just 1 and 6, 16 is divisible by 4. But since it's not divisible by 3 and by 4, then 16 is not divisible by 12. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!